Hey you, in today's video, I will, because I've got so much time on my hand, be going through a sort of review of what chemical engineering is like at the University of Melbourne. I have a lot of time on my hands. I am currently, during the winter break, resting in my house because of an ankle injury. An ankle injury that has incapacitated me into doing no sport and none of that type of stuff, which is annoying. But anyways, I'll be going through briefly the subjects, my thoughts on that, who my lecturer was, and I might just put it up on the screen what marks I got for those subjects. I don't remember them off by heart, but usually the more I like it, or the more I liked it, the better my score was, but not necessarily. There are some subjects which I enjoyed but were also really difficult. I do have some notes that I wrote down on my phone whilst I was busy doing nothing. Before I get into another sidetrack and a tangent, I have a really amazing setup here. I'm recording myself on one laptop and I'm recording my screen, which I'll move around. Very, very fancy setup. You'll just see them laid over each other, however way I'll edit it afterwards. But yeah, it will do. Honestly, I'm bored. If you're already bored, feel free to click off. I shouldn't say that. But yeah, this is just one for my own self-reflection of what I've done. And number two, I went down the route of like searching chemical engineering up on YouTube because I had the time because of my ankle injury. And I noticed that there was no Unimelb chemical engineering video or review, or really anything to do in Melbourne or in Australia, really. There's a lot of chemical engineering in the day of the life of chemical engineer, blah, 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 which was interesting. I did notice a decent amount of them turned out to be software engineers, which is a very good thing to see. But yeah, I'm just making this also for you guys, whoever's watching this, if this ever gets out. But yeah, let's get straight into it. So, for context, I am at the University of Melbourne. I am doing a Bachelor of Science, 3-year degree, majoring in chemical engineering systems. And then, in order to get accredited as an engineer, Melbourne does this sort of package where after that Bachelor of Science, you can do a 2-year, well, you should do a 2-year Masters of Engineering. And that could be in any specialty, in environmental, in electrical, in chemical, civil, all that. And that really combines into a 5-year graduate package. And after that, you'll get accredited. You will, let me bring up this fancy setup, get accredited in the Engineers Australia, which I think is the same for RMIT and Monash, and EURACE, which is a European accreditation, which I guess is extra accreditation if you want to work someplace else. You don't have to go through other stuff and training. And really, that is the gist of what the degree is. Of course, there's a traditional 4-year undergrad, and you come out being accredited as well at RMIT and Monash, versus the 3+2 getting a master's of whatever engineering you're doing at the University of Melbourne. Now, I actually enjoyed my time at Unimelb, and honestly, just go into it with the research with an open mind. I think the University of Melbourne, the Bachelor of Science, is very tailored to those who don't exactly know what they want to do, or if they're split between 2 degrees, you can actually play around with your core subjects. You choose a major first, and you have elective slots to do, which I'll get into a bit later on. So, and that was actually my position. I didn't know exactly if I wanted to get into chemical engineering or get into mechanical or electrical. I know 3 fairly different majors, but I was fairly indecisive, like a lot of students are after year 12. Who would have thought? But yeah, that's a bit of the notes that I've written down. Now, I'm only going to be really reviewing the Bachelor of Science because I'm currently in my 3rd year, in between semester 1 and semester 2. I just completed my first sem in 3rd year. So there will be a couple of subjects that I'm addressing today, which I haven't actually done because I'll be doing that next sem. But really, I'm not going to actually be going through the content of the subject itself that much. I will be touching on it. But it's just really giving an overview of what the structure of the course is like. But for most of the subjects, I will have had first-hand experience in doing that, which is lovely, lovely jubbly. Okay, so chemical engineering. Now, in the first year, I might actually whiz through the first year a bit because first year is actually pretty broad in Bachelor of Science. And as I said before, you're really playing around with what subjects you want to do on top of the electives and the core subjects. Personally, I went into, after finishing B.SCI, with a fairly good score, fairly good ATAR. I won't get into that. You can actually scour to get my marks if you'd like, you weirdos. But yeah, I did get a good score. I actually got offered Monash, but again, Monash is so far away. I live in the West Melbourne. Again, I should have said that in the context. But Monash is in the whole East Melbourne. It's pretty much an hour trek one way from west to east. And I'm not willing to do that. And I'm grateful looking back that I did not. So I ended up choosing Unimelb. Why did I ignore RMIT? I don't know, but that is the decision I made, and I'm sticking with that. So chemistry 1, you pretty much just go into learning. I think it is actually not that far off what you do from B.SCI. It's to do with reactions, to do with, I remember the term chirality or chirality, however else you'd say. I think they do teach a bit of thermo. There's reactions. It's pretty good. I think I'll put the score up on the screen if I am not lazy. Yeah, I think I did pretty well on that. Again, I think I used chemistry 1 more than I used chemistry 2, which we'll come on to later in terms of what I remember. But that's because I'm chemical engineering, and chemistry 1 isn't the Chem Eng specific. It is chemistry, and you need chemistry to do chemical engineering because you're involving the reactions or the physical changes of a chemical product or raw materials. So it is important to know and I would say chemistry 1 is a subject which you should do well in, and you should probably reflect on the content of that, and after you do it, see if you actually enjoy that, because it's not a bad indicator whether you like chemical engineering or not, again, as a first year subject. So ETS, or Engineering, Tech and Society. Now this subject I actually enjoyed a lot. We are pretty much working with a team, or it's the main project where you're designing a pipe filtration system, and you are trying to find out what is the most efficient way of delivering clean water from point A to point B, which is, I think, in a rural area. And I think it was very practical. I enjoyed it. Ray D'Agostine taught that, along with Lionel Lamb and someone else. I'm so sorry that I forgot you. I should have been more prepared. But again, off the dome, this is what I'm reviewing for you. So yeah, ETS I actually enjoyed. You also go through MATLAB. I think this is usually your first introduction to MATLAB if you're doing chemical engineering. And yes, you just get involved in group work, group projects in it, and it's really good. It's a good preparation for later subjects in later years. And I know that in masters, you're pretty much going to be involved in group work, whether you like it or not. And in the real world, you're going to be involved with people you may not personally like as well. And that is an important skill to just work through, not suck it up, actually try to work through things, but in a professional and an as effective way and manner as possible. So please do the subject. It does say elective. I would suggest doing it. But this ETS subject is a very good subject to do. And I think the lecturer Ray is actually Chem Eng as well. Actually, I know he is Chem Eng. What am I talking about? And he's a great guy. He's a great lecturer and just a great person in general. And he's a bit of a geek, a nerd in Star Wars and all that good stuff. I am as well. If you couldn't tell by my hoodie, which if you don't know what an hoodie is, you are uncultured. This is bloody Grogu or Baby Yoda. It's bloody cute. Okay, so this third subject I'm gonna completely skip. It wasn't, thank God, it wasn't a compulsory subject for me. It wasn't even a subject actually that I had to do, or didn't even exist when I started. I honestly haven't heard many good things about it. Apparently it's very broad because you pretty much do it for every Bachelor of Science student. So I'm just gonna completely whiz through that. And so calculus 2, hard subjects. I actually did enjoy it though. Again, if you don't do special or an equivalent in VC high school, you're gonna bridge. I think usually you have to bridge to Calc 1 first and Calc 2. I'm not going to go through the content of Calc 2 because I don't want to bore you or blow your brains out. No, I'm kidding. It's not that, again, I would say you could actually wrap your head in Calc 2. And again, it's not an unpopular opinion. You could wrap your head in Calc 2 more than later math subjects. And you just have to practice, and that really is in most math subject cases. I think I did well in this. Actually, I think I scraped an H1, to be honest. But that's good for me. My standards aren't the highest, aren't the lowest as well. Mom and Dad, if you're watching. But Calc 2 is a hard subject, and yes, you will need to know that when you get into chemical engineering, or if you get into most engineering fields. So if you're not that into maths, doesn't mean you shouldn't get into engineering, but you probably should have known that engineering has a decent amount of maths in it. So if you get through that, first year, first sem, donezo. That is pretty much the review of that section. And then, wow, as you can see, there's breadths, there's electives. Look at that. I should have said beforehand, because there was not that today's science, tomorrow's world subject in Sem 1, I did a breadth, and pretty much breadth is you can choose any other subject that is not in the Bachelor of Science field or realm. So I did intro microeconomics, and it was actually pretty interesting. I learned about game theory, and I learned a decent amount about supply and demand. And again, that's the beauty of it. If you can actually use it to your advantage, you get to play around with stuff, with learning other stuff outside of your initial major or core subjects like chemical engineering or bloody finance. You get to do a science subject. God forbid you bloody choose Calc 2 as a breadth, but you can technically do that if you love math and you hate yourself that much. So, semester 2, linear algebra. Again, another math subject. I would say theoretically and content-wise is actually easier than Calc 2. Matrices and a lot of manipulation which you can do, and it's actually very useful, especially if you get into programming on MATLAB and you do a bit of that on this as well. Again, it's math. If you don't like math that much, I think this would be easier than Calc 2 content-wise. But I personally did have to practice in linear algebra a decent amount still. And I think I did slightly better in linear algebra than Calc 2, if my memory serves me well. If it doesn't, then I am not sorry. So Chem 2. God, Chem 2. From what I can remember, it was just a bunch of bloody, like, nucleophilic substitution reactions. It was pretty much organic chem with, I think, a dose of thermal in it. Now, it was very interesting to learn about it, but it was also very hard to wrap my head around it. Do I use a lot of organic chem in chemical engineering? I don't think I have as much. Again, I haven't done masters yet, but hearing from those in the chemical engineering club, I doubt you do use a lot of organic chem. So it isn't the biggest focus of chemical engineering, in my opinion. It is still important to learn about reactions, but really this is just about the types of reactions and how they swap electrons and group certain areas. It's not the most interesting stuff if you are really chemical engineering focused. But I do remember the exam was pretty hard. But I think I did well as well. I think I got high 80s in Chem 2. But yeah, it's not the most interesting, and it's not the most useful for chemical engineering. For chemistry, for research chemistry, for advanced analytical chemistry, it might be. So EMD, I would probably say it's the least chemical engineering focused, but still very, very useful in terms of its practical applications. You are put into a group. I think you get to choose your groups, but randomly as well. If you've got to meet friends and are doing the exact same subject, and you so happen to be together in the same call. Well, we were in Zoom. This was second sem 2021, so back in lockdown, or pretty much most of it was online now. Yeah, it is not the most chemical engineering focused subject. The 3 projects in your group you can do is GIS, which is Geographical Information Systems or Software. To do robot, where it follows a certain path by itself. You code it, which is actually pretty cool. And you can also design a speaker, the woofer, the subwoofer, the body case, how to optimize the locations in order to get every single bass and high note and all that stuff, sort of stuff on circuits. And honestly, that was on LT Spice, and you also use SolidWorks CAD. And I went to go in that direction, and I actually met one of my now mates in that subject in my group, and it's also do chemical engineering. So whoopee, that's actually pretty good. I would say I didn't make as many friends as I would have. Actually, no, I made as many friends as I would have thought, which was a few by this point in the second semester. But yeah, so it's pretty much EMD is very project based. You are getting marks progressively based off your design, obviously on CAD, and I think you get to 3D print it if you do this in person, because we did it online, unfortunately, and you get to test it, and that would be pretty cool. And again, breadth, you get to do whatever you want. So those are your 4 subjects in Sem 2. What breadth did I do in Sem 2? I think I did a second year subject called Modeling the Real World. Introduced me to Python. Well, I did know a bit of Python beforehand, but introduced me to more algorithms and how to solve problems. They gave us an open-ended problem, and we got to work with it and present it as a final project. And I went into a betting algorithm for the Premier League, because I'm actually a pretty avid fan of the Premier League, and I actually don't bet. I don't know why I did that. It was just a fun thing to do. So first year, if you manage to go through And I did say I wasn't going to spend that much time on this, but if you do manage to go through with this, then yeah, I think you are actually a minority, or at least half of students, because I know a decent amount of people who initially wanted to do chemical engineering and didn't go through with it after first year, because that's the beauty of the Bachelor of Science degree. You actually get to choose. You get to choose what subjects and then change your major. You might have to do an extra semester or two, but yeah, you're not actually pigeonholed into a major or a degree after the first year. But after the second year, really, if you aren't into it, then I would say you will have to endure, I think, a year or at least a semester of hard catching up. Honestly, I think it gets better from first to second year. It did to me. And I got more active actually, because lockdown finally we got more relieved in Victoria, and we got to go in person, and the memories of both subjects were actually pretty decent. I'm actually going to start off with fundamentals of chemical engineering. I just need to shout out Chris Honig and Naomi Berry, those two lecturers and tutors, respectively. Those two are amazing people, amazing teachers, and just amazing people all around. I enjoyed it. The subject is pretty much just an intro to P&IDs, or just different modules. I think it's 8 modules in total in terms of reaction kinetics, reactors, heat exchangers, different valve types, different instruments to measure pressure, temperature, bloody level. It's pretty much just an intro to a lot of things you will use in your chemical engineering, and I can see myself actually using that in a lot of fields in chemical engineering. And I think the subject, and I think it's a fairly new one, I think we're over to chemical and process analysis. It's a good subject. It was well taught, and the main practical in designing heat exchanger was actually pretty fun, and we got to test it in a laboratory, and whilst it was a bit hectic and all over the place, I enjoyed it. And yeah, great subject. I think I did pretty well in it as well. Well, I keep saying well. Chuck me in a well. I am doing well, whatever. But yeah, it's a great subject. There isn't much else to say about it. You have to do the subject, but I would make the most of it. You also get to learn about HYSYS, which is this simulation of, I think, thermodynamic rules and reactions or physical chemical changes. And you have all the tools, all the equipment at your disposal. You can pretty much play around with and make any chemical process that you can find. Yeah, I would probably say that was one of, if not my favorite subjects. I really enjoyed it. And with the other subject, material and energy balances, I also enjoyed that subject. I think it was taught in the last semester that he was teaching MEB, David Shawcross. And whilst he wasn't the most engaging and great lecturer, but he was well into the years of teaching the subject, so he knew what he was saying. And I would say it is a very important subject to do. It may not be as interesting as what you do in fundamentals of chemical engineering, but it's as important, if not more, because you're pretty much dealing with in and out accumulation, disappearance, that's just the equation, and you're working with how much energy you need to put in to reach a certain temperature and flow rate of a product, and that obviously changes depending on what product it is. The thermodynamic data and properties are important. It's pretty much in the table, made and written up by David Shawcross himself, and I think assisted by Miss Sutton, Catherine Sutton, who's also a very good teacher and very kind teacher as well, who will attend to a lot of your queries and needs, because I think I asked a couple of questions as well. Great subject, but I would rank a fun CE. That's what Chris called it, fun Chem Eng. It was actually fun. And walking into it, whilst I did cringe at that statement, at least it backed up its claim of being fun. Elective, what elective did I do? I think I did sustainable and equitable energy features, or I think it was interchanging elective of breadth. And again, you get to choose whatever breadth you do. So, semester two in second year, engineering maths. I think this is the most drawing that I've ever done in a math subject before, and that's actually a positive thing. I enjoyed it. Some people hyped it up to be a very hard subject. Personally, whilst it was hard content to deal with, chemical engineering in itself isn't the easiest easiest major to do. So I am going to just say, take that with a grain of salt, put in your effort, obviously, in studying Eng maths and any of these subjects. But if you do like Calc 2, I think you'd like Eng maths. I would say it's more practical because you'll have to use, I think, a bit of that in fluid mechanics, which is a third-year subject, and I don't doubt that will also come up in later subjects, which I haven't done before. The maths, again, is important. It's the fundamentals of how you can calculate changes in temperature and take into account thermodynamic data. At the same time, you know what in is equal to out in terms of its flow rate, but its energy changes along a process that has to be computed. And again, HYSYS does that if you put in the right data. And in DPI, which is digitization in the process industries, you're pretty much given a lot of projects and tasks in both MATLAB and HYSYS to deal with those processes and to deal with analysis of certain compounds and certain mixtures and see the differences. I enjoyed the subject. I think at the end it got scaled down. And I think it's taught by Irene and Ray. Ray does the HYSYS component. Irene does the MATLAB component, and they're both very good lecturers and teachers. And yeah, that's as much as I remember. Oh yes, you get to choose your groups, and by this point I did have a good group of mates in chemical engineering to depend on, and this, but you've got to be able to communicate and also write reports and stop babbling. And I think that's also a bad habit for me to just continuously improve on as well, and I think I'm cooked. Okay, so finally, third year, reactors and catalysis. I would probably say this is the first subject where I was, first subject past first year, where I was a bit mixed about it. I enjoyed the content as much as I could. The lecture, I think Greg, but I just felt like sometimes the lectures and the lecture slides were a bit cramped and rushed. Didn't really go through the examples as well as I think he could have. Maybe give us more examples as well. I think it's very important to do the subject to differentiate between pulp flow, batch, and the mixed flow reactors, because that's pretty much the fundamentals of reactors engineering, knowing how they are different and how one is better than another in certain types of reactions, orders, in certain types of temperatures, and pretty much you're going to be using a lot of graphs and charts in reactors and catalysis. Trust me. So be prepared. It is a very dense subject. And you really touch on catalysts, that last part, only in one module. So most of it's just reactors. I think it was originally called reactors engineering because it was pretty much reactors. So fluid mechanics. I think I put more focus on reactors, but still got a greater score in fluids. But I don't think I'm the average student to just put the average effort. I think I put a bit more. So if you want to gauge how much effort you'd like to do it, fluid mech is not as dense, but it's still a fairly dense subject, teaching you about pipe flow, about Bernoulli's equation, about how you pretty much ignore friction in that equation. So you've got to incorporate it. Also pumps, mixing tanks. This is more fresh in my mind as well because I just recently did this. You go into Navier-Stokes or the assumptions to do that and to pretty much ignore a lot of the terms in the Navier-Stokes equations and the continuity equations and the momentum equations. Yes, they look daunting at first. I'll put them up on screen, but really understanding what each section is, really what the left and right hand side is, will make it easier to work through it. And you also learn the type of fluids as well, which I think was actually interesting to learn about non-nutrient fluids and bingham's and plastic fluids and all that. So I think I did better in fluids than reactors. Content-wise, I think I enjoyed fluids more than reactors. I think in the future, you're going to need both in terms of chemical engineering. But again, this is from a third-year science student who hasn't even finished their Bachelor of Science. Hopefully all of this has been helpful. So now, semester 2, elective, in the second year I also did engineering risk analysis, which I think was really good. Learning about hazards and risks, about the matrix, how to classify risk, how to pretty much document them and make sure that they're implemented. And you work in a group also in that. And third year, I think I did imaging the environment, which I think is initially called a blood subject. Blood subject meaning a lot of people just do it because it's fairly straightforward, and I think it was a fairly straightforward subject to do as well. Interesting to learn about types of satellites and cameras and types of different resolution, but is it really related? No. So we'll just skip through that. Again, so as you're doing this, as you can see, but this is why you really do an extra year, you just get to do an elective and breadth in most semesters on top of your core subjects. So you're not going to be doing fully chemical engineering in this Bachelor of Science. Most of it is chemical engineering, and then you get to do side subjects of your own choice. And personally, I enjoyed that model. But if you are dead set before you get into uni about chemical engineering, then honestly, I would suggest maybe saving a year off and go to RMIT or Monash or any other engineering school that offers the 4-year undergrad. Semester 2, process safety and sustainability case studies and momentum mass need transfer. I haven't done these subjects, as I've said. That is next semester. I'm currently waiting. I'm so excited. Okay, I am actually excited, but they do sound pretty daunting. But I think Chris is going to teach that subject, so I'm looking forward to that. Genuinely, it's going to be a good subject. I think safety is very important in chemical engineering and in most engineering. But if you're dealing with chemicals and converting raw material and minerals and chemicals into a product, you're going to be dealing with a lot of hazards. And I think process safety is a very important thing that was drilled into us in Chem Eng, and I think in most subjects. I think we had to do a bloody prac in MEB as well, reviewing a safety incident case. And I think I did a Cuban explosion of an oil storage plant because somebody forgot to replace the level indicator. But we'll see. I think if I do a master's review, I'll touch on those last 2 subjects. Momentum mass and heat transfer, I think that's a build up from MEB and Chem Eng. And I think that will be, again, a dense subject. I think it's taught by Irene, which we had, for DPI, digitalization of the process industries. I don't have much expectations of that. I don't know if it's going to be the best or the worst, but I reckon it's going to be a good subject. Hard subject, but still a good subject. In my opinion, I think the chemical engineering department is great. The teachers, most of them are great people, great lecturers. And yeah, that is pretty much the Bachelor of Science.